Hi folks, so the question we're going to be doing today is based off of an ellipse and a parabola. Okay, it comes from the Understanding Graphics textbook, and the reason we're going to actually be doing this question is because for higher level technical drawing students, it teaches us one of the kind of important principles of how to construct an ellipse when you're only given, say, a minor or a major axis and a point on the curve. Okay, so that's what we're going to be doing today, and then obviously there's going to be a little bit of recap on parabolas as well. So starting off, we're always going to read the question, see what it tells us about the question. So the question says, the figure below represents the outline elevation of a stadium. So we can see the elevation view here. The curve ABC is a semi-ellipse with minor axis 120 millimeters. Okay, so they're telling us what the minor axis is. It's 120 millimeters. So we're going to look for the curve ABC, and we can see the minor axis obviously then is 120, 60 plus 60. So my radius for a minor circle is going to be 60 millimeters. Okay, so that's important information there. The curves DEF and D1E1F are based on the same parabola with vertices located at E and E1 respectively. Okay, so that means basically the curves here DEF and D1E1F are based off the same ellipse. Okay, so essentially once you get one, you can use axial symmetry to get the other. And the vertices are at E and E1. Okay, so that's important as well. And then it says, draw the outline of the building showing all construction clearly. Okay, so what we actually are faced with here is a minor axis. We're given the minor axis, so we can get the minor auxiliary circle, and we have a point on the curve as well. We do not know the length of the major axis up to B, so that's what we have to find out. We're going to have to find the major auxiliary circle, so when we're starting. So I can see the minor axis, I can draw on my minor circle, and then on top of that I can locate a point on the curve. And that point there on the curve is up 64, and from out here, so out 20 from A, it's going to be in 33. Okay, so that point there from A, it's going to be from A out 20, and then up 64, and then in 33 from there. Okay, so that's the first thing I'm going to do. I'm going to set up my minor circle and locate that point there. Okay, the point here is the same at the opposite side. Alright, so as you can see there, I have set up my baseline here already. I set up the line going through the middle, so that's going to be my center point for my minor circle, and the distance from here to here is 60. I'm also going to measure out to 20. Okay, measure out to 20, and I'm going to project the line up there because I want to find my point that is on my ellipse first of all, and that point is up there, and it's up a height of 64, which I've measured here already previously. That height is up 64, and that is going to be in 33 is what it said. So that point that is on the curve, technically that's a point P that's on the curve. So I'll label that point P. I'll do the exact same at the opposite side just to have it done as well. So mark out 20, project up, and just to be able to locate that point as well on the opposite side, mark in 33 on the opposite side as well. And there is another point P on my curve as well. I'll need to use one of them for this construction that we're going to do. Okay, so the next step now, what we have to do is we're going to work backwards to find our major axis. So what I would first do is, I'm given the minor auxiliary axis, which is from here to here, which is 60 millimeters. So I put in my minor circle, my minor auxiliary circle. So we can see the minor auxiliary circle there. Okay, and now what we have to do, and I would always do this as well, I would locate the direction of my major axis. So I know my major axis is this guy up here. Okay, so I'm just going to put in MAJ, and I'm going to say that the major axis is going up and down like that. Okay, so we can see the direction of it there, MAJ going up and down. I know my minor is out here, so this is my minor axis. I'll just put it out here, just out of the way of the drawing, and it is going from left to right. Okay, so the method for this is, when we have a point on the curve and we want to find either the major or the minor, what we do is the one we're trying to find, we go parallel to that first, okay? And the one we're trying to find here is the major auxiliary circle. So the major axis we know goes up and down. So from our point, what we're going to do is we're going to follow the same direction as the major axis. We're going to go parallel to it from a point that is given to us on the curve. So from P, I'm going to go parallel to the major axis to intersect the minor circle at this point here. Where it cuts the minor circle there, I'm going to join it to the center point and extend out. And where it extends out to, and I extend it beyond, and then I go parallel to the minor axis, where those two lines meet at that point there, looks like it's actually close enough to the 20 mark that I measured out, that is going to be the radius of my major axis. So now, just that simple method there, from the point, go parallel to the major, because that's the one we're trying to find, to intersect the minor circle. Where it intersects the minor circle, I join it to the center and I extend it out. And from the point again, I'll go parallel to the minor to cut it. And where it cuts it, that's going to be my radius. Okay? And now, using that radius, I'm going to get my major auxiliary circle, which is there. And at this point now, it is a simple concentric circles method to complete the ellipse. Okay, so I'm going to speed up the video there now. Okay, so the next part of this question involves getting the parabolas. As you saw there, we got the ellipse by getting the minor circle and using a point on the curve to locate our major. Now what we have to do is we have to focus on these ellipses, or sorry, these parabolas up here, DEF and D1E1F as well. So what I'm actually going to focus on is the one here, DEF, and when I find that, I'll be able to use axial symmetry to get it on the opposite side. Now the part of the parabola I'm actually going to focus on is the portion from E to F here, and we'll get D after by using a bit of axial symmetry there to locate a point maybe that's here and find the exact mirror image of it over here as well to find the actual position of D, because D cuts the same line as where our initial point on our curve was, which is in 33. So what I'm actually going to do is we're going to use the rectangle method to complete the parabola. So we're going to use a rectangle that is 40 long, so it was initially up 64 plus 16, so it's up 80 to find E from out here, so it's up 80 and then up another 40, okay, and then in 80 as well. 33 and 47 is in 80 up here. So I actually have some of these points located. I have F located already, I just have to find E, and I'll make that little rectangle there if you can see it. Just follow the trace of my pencil, okay, and then we're going to use the rectangle method to complete our parabola. Okay, so I'll just find those points there now. So I have a height here already measured up, which is 80, and just going to locate my E, and my E is going to be somewhere in there, right there is going to be my E. I also forgot earlier on to label my ellipse. That was A, B and C, very important to label. Okay, and now what I want to do is I want to find F, and I already have F, but that was up here where my major was, so I'm just going to get rid of that now because we don't need that anymore. We've used that information, and now that information is going to become my F. Okay, and where F is there, I'm going to create a box, a rectangle, and as we can see there, I have my rectangle literally from here to here to here to here. Now what I'm actually going to do is, we don't have to use division of lines here, we can use a simple bit of maths. The measurement from here up to here is 40, and the measurement from here to here is 80. So simple maths, I'm going to use 40 divided by 4 is 4 tens, so I'm just going to measure up 4 tens there. I'm going to go 10, 10, 10, and 10 is the last one. and then 80 divided by 4 would be 4 20s. So I'll do 20, that's right, 20, 20, and with 20 left over. And as you can remember, they said E was our vertex, so that actually means the axis of our parabola is this line here. So that means from these measurements here on the outside, they all go parallel to my axis, like that. And I know I'm going to have to use axial symmetry, so I'll extend them on as well to get it on the opposite side. Okay, so now at these points up here, I'm going to connect all of them to my vertex, which in this case is E. Connect that one to the vertex, same with the next one, same with the last one. And that will help me locate points on my curve. Now we know E and F are already points, so there and there, but just to locate the rest of them, so the furthest one away from F to the furthest one away from F to the closest one to E, that'll give me a point there. Then the next one down to the next one away gives me a point here. The last one away to the last one down gives me a point here. And what we can see there is the kind of curvature of our parabola. So just sketch that in there, so I'll speed up the video there quickly. Okay, now we can see that I have the first part of my parabola from E to F done. Now I'm going to find the exact same on the opposite side. So just locate where E1 was on the opposite side. So if I just extend that up, that'll give me where E1 is, which will be over here. Just make sure I bring the right one across actually, sorry, mixed it up. That's where E1 will be, right there. And now what I want to do is I want to find points in this part of the curve as well. So I'm just going to use a bit of axial symmetry there. So I'll take the distance from the middle to here and project it out the opposite side. The exact same for the next point up. Just make sure you take the right distances, the right points. And the exact same thing here for the last one. That distance there, project it out to the opposite side. And once again, just going to speed up the video there while I'm drawing in the curve. Okay, just on the last portion there now, we have completed the portion from E to F, and we've also completed the portion from E1 to F as well. Now what we have to do is just get this little bit down here. And as we can see, we've already got this line, this guideline in here already. So it's literally a case of just using axial symmetry, only instead of using this line this time, we're going to use this line that will be running across our page there like that, okay? And what we're going to do is take a point roughly in here that eventually will extend the curve maybe beyond a little bit, so that we can find where D1 and D are respectively. And then when we find them, we can just join them up down here to the corners to complete the question, okay? So just speed up the video there now once again, because that bit there is quite easy. So just before I speed it up, I'm going to take a point. I'll take this one, I'll take this one, and I'm actually going to take, I will take all three of them actually. It's just the easiest thing, okay? So I'll speed up the video there now. Okay guys, there's the question completed. Just as you can see there, I used another little bit of axial symmetry to get my points on the opposite side down here to locate my points D and D1 respectively. So that one was D and this was D1. I initially said I was going to take down 3 points here, but I actually only needed 2 as it turned out. You can see where the continuation of my parabola was, and I stopped my parabola at where it intersected this line here, okay? Little bit in that question, very useful, a bit of practice on parabolas, using a bit of axial symmetry, but the most important point in that question was actually the start where we did the ellipse, given the minor circle and the minor axis and a point on the curve, and we had to find the major to complete the question. Hope you found that question useful there guys. That's the question completed there.